YAML is a human-readable data serialization format that takes concepts from programming languages such as C, Perl, and Python, and ideas from XML in the data format of electronic mail. YAML was first proposed by Clark Evans in 2001, who designed it together with Ingy paragraph T Net and Oren Ben-Kiki. It is available for several programming languages. YAML is a recursive acronym for YAML Ain't Markup Language. Early in its development, YAML was said to mean yet another markup language, but it was then reinterpreted to distinguish its purpose as data-oriented, rather than document markup. Features: YAML syntax was designed to be easily mapped to data types common to most high-level languages: list, associative array, and scalar. Its familiar indented outline and lean appearance make it especially suited for tasks where humans are likely to view or edit data structures, such as configuration files, dumping during debugging, and document headers. Although well suited for hierarchical data representation, it also has a compact syntax for relational data. Its line and whitespace delimiters make it friendly to ad hoc grep Perl Ruby operations. A major part of its accessibility comes from eschewing the use of enclosures such as quotation marks, brackets, braces, and open-close tags, which can be hard for the human eye to balance in nested hierarchies. Examples: sample document, data structure hierarchy is maintained by outline indentation. Notice that strings do not require enclosure in quotations. The specific number of spaces in the indentation is unimportant as long as parallel elements have the same left justification and the hierarchically nested elements are indented further. The sample document defines an associative array with 7 top-level keys. One of the keys, items, contains a 2-element array, each element of which is itself an associative array with differing keys. Relational data and redundancy removal are displayed. The ship to associative array content is copied from the build to associative arrays content as indicated by the anchor and reference labels. Optional blank lines can be added for readability. Multiple documents can exist in a single file stream and are separated by an optional. Can be used at the end of a file. Language elements, basic components of YAML. YAML offers both an indented and an inline style for denoting associative arrays and lists. Here is a sample of the components. Lists. Conventional block format uses a hyphen plus space to begin a new item and list. Optional inline format is delimited by comma plus space and enclosed in brackets. Associative arrays. Keys are separated from values by a colon plus space. Indented blocks, common in YAML data files, use indentation and new lines to separate the key, value pairs. Inline blocks, common in YAML data streams, use comma plus space to separate the key, value pairs between braces. Block literals, strings do not require quotation. New lines preserved. By default, the leading indent and trailing white space is stripped, though other behavior can be explicitly specified. New lines folded. Folded text converts new lines to spaces and removes leading white space. Hierarchical combinations of elements, lists of associative arrays. Associative arrays of lists. Advanced components of YAML, 2 features that distinguish YAML from the capabilities of other data serialization languages are structures and data typing. Structures. YAML structures enable storage of multiple documents within single file, usage of references for repeated nodes, and usage of arbitrary nodes as keys. Repeated nodes, for clarity, compactness, and avoiding data entry errors, YAML provides node anchors and references. References to the anchor work for all data types. Below is an example of a queue-in instrument sequencer in which 2 steps are reused repeatedly without being fully described each time. Data types. Explicit data typing is seldom seen in the majority of YAML documents since YAML auto-detects simple types. Data types can be divided into 3 categories: core, defined, and user-defined. Core are ones expected to exist in any parser. Many more advanced data types, such as binary data, are defined in the YAML specification but not supported in all implementations. Finally, YAML defines a way to extend the data type definitions locally to accommodate user-defined classes, structures or primitives. Casting data types, YAML auto-detects the data type of the entity. Sometimes one wants to cast the data type explicitly. The most common situation is a single-word string that looks like a number. Boolean or tag may need disambiguation by surrounding it with quotes or use of an explicit data type tag. Other specified data types. Not every implementation of YAML has every specification-defined data type. These built-in types use a double exclamation sigil prefix. Particularly interesting ones not shown here are sets, ordered maps, timestamps, and hexadecimal. Here's an example of base 64 encoded binary data. Extension for user-defined data types. Many implementations of YAML can support user-defined data types. This is a good way to serialize an object. Local data types are not universal data types but are defined in the application using the YAML parser library. Local data types use a single exclamation mark. Syntax. A compact cheat sheet as well as a full specification are available at the official site. The following is a synopsis of the basic elements. YAML streams are encoded using the set of printable Unicode characters either in UTF-8 or UTF-16. For JSON compatibility, the UTF-32 encodings must also be supported in input. White space indentation is used to denote structure. However, tab characters are never allowed as indentation. Comments begin with the number sign, can start anywhere on a line and continue until the end of the line. Comments must be separated from other tokens by white space characters. Unless they appear inside of a string, then they are number sign literals. List members are denoted by a leading hyphen with one member per line, or enclosed in square brackets and separated by comma space. Associative arrays are represented using the colon space in the form key, value either one per line or enclosed in curly braces and separated by comma space. An associative array key may be prefixed with a question mark to allow for liberal multi-word keys to be represented unambiguously. Strings are ordinarily unquoted, but may be enclosed in double quotes, or single quotes. Within double quotes, special characters may be represented with C-style escape sequences starting with a backslash. According to the documentation, the only octal escape supported is \0. Block scalars are delimited with indentation with optional modifiers to preserve or fold new lines. Multiple documents within a single stream are separated by 3 hyphens. 3 periods optionally end a file within a stream. Repeated nodes are initially denoted by an ampersand and thereafter referenced with an asterisk. Nodes may be labeled with a type or tag using the exclamation point followed by a string, which can be expanded into a URI. YAML documents in a stream may be preceded by directives composed of a % followed by a name and space delimited parameters. 2 directives are defined in YAML 1.1. The %YAML directive is used to identify the version of YAML in a given document. The %TAG directive is used as a shortcut for URI prefixes. These shortcuts may then be used in node type tags. YAML requires that colons and commas used as list separators be followed by a space so that scalar values containing embedded punctuation can generally be represented without needing to be enclosed in quotes. 2 additional sigil characters are reserved in YAML for possible future standardization, the @ and accent grave. Comparison to other data structure format languages, while YAML shares similarities with JSON, XML and STL, it also has characteristics that are unique in comparison to many other similar format languages. JSON syntax is a subset of YAML version 1.2, which was promulgated with the express purpose of bringing YAML into compliance with JSON as an official subset. Though prior versions of YAML were not strictly compatible, the discrepancies were rarely noticeable, and most JSON documents can be parsed by some YAML parsers such as Cyc. This is because JSON semantic structure is equivalent to the optional inline style of writing YAML. While extended hierarchies can be written in inline style like JSON, this is not a recommended YAML style except when it aids clarity. YAML has many additional features lacking in JSON, including comments, extensible data types, relational anchors, strings without quotation marks, and mapping types preserving key order. XML and SDL, YAML lacks the notion of tag attributes that are found in XML and SDL. For data structure serialization, tag attributes are, arguably, a feature of questionable utility, since the separation of data and metadata adds complexity when represented by the natural data structures in common languages. Instead, YAML has extensible type declarations. YAML itself does not have XML's language-defined document schema descriptors that allow, for example, a document to self-validate. However, there are several externally defined schema descriptor languages for YAML that fulfill that role. Moreover, the semantics provided by YAML's language-defined type declarations in the YAML document itself frequently relaxes the need for a validator in simple, common situations. Additionally, YAXML, which represents YAML data structures in XML, allows XML schema importers and output mechanisms like XSLT to be applied to YAML. Indented delimiting, because YAML primarily relies on outline indentation for structure, it is especially resistant to delimiter collision. YAML's insensitivity to quotes and braces in scalar values means one may embed XML, SDL, JSON or even YAML documents inside a YAML document by simply indenting it in a block literal. YAML may be placed in JSON and SDL by quoting and escaping all interior quotes. YAML may be placed in XML by escaping reserved characters, and converting white space. Or by placing it in a CDATA section. Non-hierarchical data models, unlike SDL and JSON, which can only represent data in a hierarchical model with each child node having a single parent, YAML also offers a simple relational scheme that allows repeats of identical data to be referenced from two or more points in the tree rather than entered redundantly at those points. This is similar to the facility IDREF built into XML. The YAML parser then expands these references into the fully populated data structures they imply when read in, so whatever program is using the parser does not have to be aware of a relational encoding model, unlike XML processors, which do not expand references. This expansion can enhance readability while reducing data entry errors in configuration files or processing protocols where many parameters remain the same in a sequential series of records while only a few vary. An example being that ship to and bill to records in an invoice are nearly always the same data. Practical considerations: YAML is line-oriented and thus it is often simple to convert the unstructured output of existing programs into YAML format while having them retain much of the look of the original document. Because there are no closing tags, braces, or quotation marks to balance, it is generally easy to generate well-formed YAML directly from distributed print statements within unsophisticated programs. Likewise, the whitespace delimiters facilitate quick and dirty filtering of YAML files using the line-oriented commands in grep, awk, Perl, Ruby, and Python. In particular, unlike markup languages, chunks of consecutive YAML lines tend to be well-formed YAML documents themselves. This makes it very easy to write parsers that do not have to process a document in its entirety before they begin extracting specific records within. This property is particularly expedient when iterating in a single, stateless pass, over records in a file whose entire data structure is too large to hold in memory, or for which reconstituting the entire structure to extract one item would be prohibitively expensive. Counterintuitively, although its indented delimiting might seem to complicate deeply nested hierarchies, YAML handles indents as small as a single space, and this may achieve better compression than markup languages. Additionally, extremely deep indentation can be avoided entirely by either, 1. Reverting to inline style without the indentation. or 2, using relational anchors to unwind the hierarchy to a flat form that the YAML parser will transparently reconstitute into the full data structure. Security. YAML is purely a data representation language and thus has no executable commands. This means that parsers will be safe to apply to tainted data without fear of a latent command injection security hole. For example, because JSON is native JavaScript, it is tempting to use the JavaScript interpreter itself to evaluate the data structure into existence, leading to command injection holes when inadequately verified. While validation and safe parsing is inherently possible in any data language, implementation is such a notorious pitfall that YAML's lack of an associated command language may be a relative security benefit. However, YAML allows language-specific tags so that arbitrary local objects can be created by a parser that supports those tags. Any YAML parser that allows sophisticated object instantiation to be executed opens the potential for an injection attack. Perl parsers that allow loading of objects of arbitrary class create so-called blessed values. Using these values may trigger unexpected behavior, for example if the class uses overloaded operators. This may lead to execution of arbitrary Perl code. The situation is similar for Python parsers. According to the PIM documentation, note that the ability to construct an arbitrary Python object may be dangerous if you receive a YAML document from an untrusted source such as the Internet. The function YAML safe load limits this ability to simple Python objects like integers or lists. Data processing and representation. The XML and YAML specifications provide very different logical models for data node representation, processing, and storage. XML. The primary logical structures in an XML instance document are 1. Element, and 2. Attribute. For these primary logical structures, the base XML specification does not define constraints regarding such factors as duplication of elements or the order in which they are allowed to appear. In defining conformance for XML processes, the XML specification generalizes them into two types, 1. Validating, and 2. Non-validating. The XML specification asserts no detailed definitions for an API, processing model, or data representation model. Although several are defined in separate specifications that a user or specification implementer may choose independently. These include the Document Object Model and XQUEOI. A richer model for defining valid XML content is the W3C XML schema standard. This allows for full specification of valid XML content and is supported by a wide range of open-source, free and commercial processors and libraries. YAML. The primary logical structures in a YAML instance document are 1. Scalar, 2. Sequence, and 3. Mapping. The YAML specification also indicates some basic constraints that apply to these primary logical structures. For example, according to the specification, mapping keys do not have an order. In every case where node order is significant, a sequence must be used. Moreover, in defining conformance for YAML processes, the YAML specification defines two primary operations, 1. Dump, and 2. Load. All YAML-compliant processes must provide at least one of these operations, and may optionally provide both. Finally, the YAML specification defines an information model or representation graph, which must be created during processing for both dump and load operations, although this representation need not be made available to the user through an API. Implementations, pitfalls and implementation defects, editors. An editor mode that auto-expands tabs to spaces and displays text in a fixed-width font is recommended. Tab expansion mismatch is a pitfall when pasting text copied from web pages. The editor needs to handle UTF-8 and UTF-16 correctly. Strings. YAML allows one to avoid quoted strings, which can enhance readability and avoid the need for nested escape sequences. However, this leads to a pitfall when inline strings are ambiguous single words or when the unquoted phrase accidentally contains a YAML construct. This is not an issue that anyone using a proper YAML emitter will confront, but can come up in ad hoc scripts or human editing of files. In such a case, a better approach is to use block literals rather than inline string expressions, as these have no such ambiguities to resolve. Anticipating implementation idiosyncrasies, some implementations of YAML, such as Perl's YAML PM, will load an entire file and parse it en masse. Conversely, YAML Tiny only reads the first document in the stream and stops. Other implementations like PIML are lazy and iterate over the next document only upon request. For very large files in which one plans to handle the documents independently, instantiating the entire file before processing may be prohibitive. Thus in YAML PM, occasionally one must chunk a file into documents and parse those individually. Fortunately, YAML makes this easy, since this simply requires splitting on the document separator, which is M as a regular expression in Perl. Portability: simple YAML files are readily parsed with regular expressions without resort to a formal YAML parser. YAML emitters and parsers for many popular languages written in the pure native language itself exist, making it portable in a self-contained manner. Bindings to C libraries also exist when speed is needed. C libraries, libyaml. As of June 2007, this implementation of YAML 1.1 is stable and recommended by the YAML specification authors for production use. There is a tutorial on its use. This implementation is available under the MIT license. SYCK, this implementation supports most of YAML 1.0 specification and is in widespread use. It is optimized for use with higher-level interpreted languages, obtaining speed by writing directly to the symbol table of the higher-level language when it can. As of 2005, it is no longer maintained but remains available. This implementation is available under the user's choice of two licenses: the two-clause BSD license, and an unusual death and repudiation license, which restricts its use to dead people only. C++ library, YAML CPP C++ YAML library, compatible with YAML 1.2 spec, bindings, native implementations and C libraries. Bindings for YAML exist for the following languages: ActionScript, AS3 YAML direct port of JVYAML for ActionScript 3, C. YAML.NET provides low-level parsing and emitting of YAML as well as a high-level object model similar to XML document, YAML library for .NET. YAML parser and C, an almost feature-complete YAML parser written in C, YAML for .NET, Visual Studio and PowerShell, YAML, YAML-typed YAML library for Erlang, YAML based on libyaml, load-only, Go, YAML based on libyaml but written entirely in Go, Haskell, YAML reference implementation of YAML syntax and utilities, YAML binding to libyaml, HSSYCK interface to SYCK, JSON2 YAML conversion, Java, JVYAML based on Cyc API, and patterned off RBYAML, GYAML pure small Java implementation, Snake YAML YAML 1.1 parser and emitter for Java 5, JavaScript, JSYAML full-featured YAML 1.2 parser and emitter written entirely in JavaScript, Common JS YAML, covers a small subset of YAML, JavaScript YAML parser, JSYAML code on Stack Overflow, Lua Cyc, YAML. libyaml binding, OCaml, Cyc, Objective-C, YAML framework based on recommended libyaml, CiteCocoa, Perl, YAML, a common interface to several YAML parsers. YAML Tiny implements a useful subset of YAML. Small, pure Perl, and faster than the full implementation. YAML Cyc binding to SYCK library. Offers fast, highly featured YAML, YAML XS binding to libyaml. Better YAML 1.1 compatibility. YAML only detect the best available YAML implementation and wrap that with the standard YAML API. PHP, Spike, a pure PHP implementation, PHP Cyc, Symfony YAML component was initially released as part of the Symfony framework. PECL YAML, Python, PIM highly featured. Pure Python or optionally uses lib.yaml. PySec, binding to SYCKC library, Ruby, YAML included in standard library since 1.8. Based on SYCK, YA2 YAML with full UTF-8 support, ZAML far faster than default library, YAML, a YAML parser in pure Ruby, CRAN YAML, Scala, Scala YAML, TCL, available as of TCL 8.4, XML, YAXML, see also, comparison of data serialization formats, list of lightweight markup languages. Other human-readable serialization formats include ASCII doc, JSON, the JavaScript object notation discussed above, OGDL, PLIST, the object serialization format from NextStep, S expressions, simple outline XML, XUPL C-style equivalent to XML, candle markup, unified markup and object notation, notes and references. External links, YAML quick reference card, YAML.org, YAML specification, YAML improves on XML. Intro to YAML in Python.